Assalamu alaikum wa rahmatullahi wa barakatuh. With you, Mr. Sharif Abbas from Rima International School. Today, inshallah, we will take another lesson from grade 6, unit 4, lesson 2, the periodic table. We speak at the last session about the atom and how they're important for us. They are so small, what we found inside the atom, what's the particles inside the atom, what is the charge of them, what is the atomic number and mass number. Today we will speak about the periodic table. What's the periodic table? How we can benefit from the periodic table and why we make it. First, I want to ask you a question. If you go to a market, a very huge market, but this market, it is not organized. That means everything you can find it everywhere. Okay, so if you want to search, as example, about an apple, okay, you will take a lot of time because the fish with meat, with an egg, with the cheese, with the vegetables, with fruits, it is all of them at everywhere. They are not organized. But if you go to another market, this market is organized. There is a section for vegetables, other section for a fruit, other section for a meat. You will find what you want very easily. That is the point, the main point of the periodic table. The scientists try to put all the elements which we found at a table so they can study them very easily and note the properties of all of them. Okay. First, what is the element? We speak about the atom, and we know that we have a lot of element, which of course composed from the element is one element composed from an atom. Okay, so the element is a substance that can't be broken down into any other substance. Okay, the old people think that all things in our life, our earth, come from only four matters. What is this four matters? It is fire, wind, earth, and water. Okay, but at 18th century, okay, they changed the opinion, changed their mind, and they speak about, or they found a lot of matters, a lot of other matters, a lot of elements. They found at least 60 different basic substances which they found at the natural and use it. Like what? Like oxygen, O, hydrogen, H, sodium, Na, magnesium, Mg, and a lot of things, iron, Fe. Okay. This basics or this physical elements, they have a different, these elements have different physical and chemical properties. Okay, but they don't think about properties now. They can't classify them about only the properties, but an example about the properties, like the shiny. We have here the sulfur, it's not shiny, but the mercury, it is very shiny. Okay. The first one who try to arrangement or organize the element is a Russian chemist named Dmitry Mendeleev. Dmitry Mendeleev began thinking about how he could organize the element based on their properties. Okay, and he make a cards. These cards, okay, he order them about the mass number of the element. About what, guys? About the mass number of the element, and he make a card with elements properties. These cards, after a while, they call it periodic table. So the periodic table, we found it at the Dmitry Mendeleev cards. But at 19th century, okay, early 19th century, we have a British scientist. We call it Henry Moseley. Henry Moseley, guys, make a new arrangement. He tried to fix a lot of mistakes at Dmitry Mendeleev table, okay, and rearrange the elements about not mass number, no. He arranged them about by the atomic number. By what, guys? by atomic number. So Moseley's new arrangement of the element corrects some of the flaws in Mendeleev table. This periodic table is useful to the scientists because they make clear many patterns among the elements' properties, and the periodic table is like a map or calendar of the elements. So we can know the elements and know the properties of them. Okay. That is the shape of the periodic table, guys. Okay, let's erase this first. Okay, don't worry about my written, I'm so sorry, but listen to me. Let's check the periodic table. First, we will know that we have about more than 100 elements. Here at this table we have 118 elements. That is the last one, 118 element. Okay. If you focus with me, you will find a lot of colors we have. We have the background color, we have a purple, we have blue, and we have an orange, black background color, and we have some what we can say, some letters. These letters, maybe it will be written with black or red or green. So what's the difference between them? First, you must know that everything with background, blue background, that we call it metals. We call it what, guys? We call it metals. So all of this blue parts, we call it metals. Okay, I think you see it. Okay, but the purple one, we call it non-metal. The purple one, we call it non-metal. I will change this color because yes, it's very small. We will make it big. Yes. That's purple one, we call it non-metal. And what about the orange one, which we found at the middle? The orange one, guys, the orange one, it is metalloid. The orange one, it is metalloid here. That is a metalloid. Okay, guys? So we have three kinds of background colors: metals and non-metals and metalloids. Okay, what else? What we can find or focus else in this periodic table? The periodic table, guys, composed from columns. If we count them, we will find it 18 columns. 18 columns. Every one of these columns, okay, guys, we call it group or family. So we have 18 group or 18 family. Every element at the same family have the same properties. All the elements at the same family have the same properties, and we will speak about it after a while. Okay, what else? Okay, we have here 7 rows. 7 rows, guys. Look. That is the rows. Okay, we have 7 rows, and this rows we call it period. So if I ask you how many group we have at the periodic table, we have 18 group. We have 18 group or family. But how many periods we have? It's only 7. It's only what, guys? 7. Okay, let's speak about the color of the symbols itself. If the symbol was written with a black, as you see here, that means it is a solid. It is what, guys? Solid. But if it is written with a red color, it means it is liquid, like mercury here. Okay, we have only 2 liquids, mercury and bromine here. Only 2, this and this. Okay, and if it is written with a white color, that means it is gas. So solid, it's black, red, it is liquid, and white, it is gas. What about the green one? The green one, that means it is not found yet. It's not found yet. Okay, or not yet known. They give it numbers and symbols, and they search about that. If we found any element after a while, inshallah, the future, with the same atomic number, we will put here. Okay, guys? Okay, let's speak about the symbol itself. If you focus, we have here, I will take a one from them. Okay, if I take one of them, okay, and speak about it. Okay, we have here the Fe. Fe, it is iron. Oh, I can hear one student ask me why iron written with Fe. The symbol, it must be the what, guys? The first or second, the first or second and third letters from the name of the element itself. Okay, but here we know that the iron start with I and R. Why we didn't put it IR or I for iron? Because this element, we found it from ancient time, and they gave its name by a Latin word. Okay, so as a Latin word, it's called ferrous. Ferrous. The first letters, it's F and E. Okay, and we found a small number 26 and big number 55.85. That's approximately 56. Okay, and we know before the 26, it is what, guys? It is the atomic number, and the big number 56, it is the mass number. Okay, we speak about these parts before. Okay, let's go to the next page. We will back to the periodic table, but after a while. So that is the symbol aluminum as example. The first number here, 13, it's atomic number. The biggest number, it is for the atomic mass, and we said before the atomic number, it's referred to the number of protons or number of electrons, because they are the same, and the biggest number, it's referred to number of protons plus number of neutrons. Okay, and we have here the chemical symbol. It is the first letters, and must be always capitalized, okay, like A, but second letter, it must be small. Okay, and the chemical name of the atom. Okay, good. Okay, Shafin. What about the properties of the metals and non-metals and metalloids? First, you must know that the metals have a lot of same properties. Like what? All the metals are shiny. All the metals can conduct heat and electricity very well. All the metals, guys, malleable, and all the metals are ductile. Okay, so that means we can make a shapes, a thin sheets from the metals like aluminum foil, and we can make a wires from the metals. Okay, the non-metals, it is all the properties of non-metals. It is like what? It is poor conductor of electricity and heat, and they are dull and brittle. They don't have metallic shiny. Okay, they can't make sheets. They can break easily. We can't make wires from them. That is non-metals. What about metalloids? Metalloids have some properties from metals and other properties from non-metals. An example of the metalloids is silicon, and we use silicon at the electric devices. A lot of electric devices will use silicon inside it. Okay. And we said before, each vertical column of elements, we call it a group or family. Okay, the properties of element in a group are similar because the atom of these elements have the same number of valence electron. That is a very important thing. What is a valence electron, guys? What is a valence electron? I will erase this. Valence electron. The valence electron, that is the electrons which we found at the last energy level of the atom. Okay, so valence electron are found in outermost portion of electron cloud of the atom. Mister, I don't understand this part. I will explain it for you because it's very important, so please focus with me. I will take an example, Na, which we call it sodium, okay, and it have 11 electrons. Okay, guys, if you remember, we speak about the Bohr model before, and we said that the Bohr said that the element that have an orbit, the electron move inside an orbit. Okay, this orbit we call it energy levels. Every energy level can have a number of electrons. They are different from a level to another level. So focus with me. Bohr said that the first level, we have as example Na, that have 11 electrons. How I can distribute these electrons with Bohr model? The first level always take 2 electrons only. The first level always take 2 electrons only, but the second, the third, the fourth, and etc., they can hold up to 8 electrons. They can hold up to 8 electrons. Okay, they can hold up to 8 electrons. How, yeah, mister? I can't understand this part. I will explain it for you. First, let's speak about sodium. It have 11 electrons, so I will put Na. That is the nucleus. Okay, around the nucleus we found the first energy level, and this at the first energy level we will take only 2 electrons. Why? Because we said that the first energy, it always take 2 electrons only. He can't hold more than 2. That is the first energy level. Okay, let's go to other level. Second level, we have 11, we take from them 2, so we still have 9. Okay, the second energy level, it will have we said that second can hold up to 8, and we have 9, so I will take 8 as second one. 1, 2, 3, 4, 5, 6, 7, 8. So now how many electrons we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that is 9, 10. Okay, we still have 1 electron, so it will go to the last energy level, outermost shield, and we will put 1 electron. So that is our electron. That's what we call it, valence electron. That's what we call it. What, guys? Valence. I will change this. Let's make it with okay, green. Okay, that is our what, guys? That is our valence electron. So valence electron again. What is a valence electron? Valence, V-A-L-E-N-C-E, valence electron. The valence electron, guys, it is the electrons which we found it at the outermost shield of the atom. So sodium have only 1 electron, valence electron, and this valence electron is very important. Why? Because all the chemical bonding, it's depending on the valence electron. Okay, We will speak about this part inshallah at next lesson, but what we will need to know now. Okay, I will take another example to know more about the valence electron. Let's go to the periodic table. Let's take lithium. Lithium have 3 electrons. Okay, we'll go to another page. Lithium, guys, Li3. So let's distribute. That is a nucleus of the lithium. The first level will hold only 2 electrons. Okay, the second one will hold 1 electron, and that is the valence electron. So the valence electron in lithium, it is only 1. Okay, guys, can you note something here? If you focus, if you focus here, guys, lithium have only 1 valence electron, and sodium also have only 1 valence electron. Oh, and both of them at the same group. So all the elements at the same group have the same valence electron. That's mean group 1, we have a rule now. Focus with me, guys. This rule, I will speak about it inshallah again at the next session, but focus with me. Group 1 have only 1 valence electron. But group 2 have from its name 2 valence electron. Focus, guys, with me. It's very important. All the elements at the group 2 have 2 valence electron. Okay, what about group 3 and 4 and 5? I will make it like this. From, guys, focus with me, from 3, from here to here, to group 12, we will not speak about it because it have a different what, guys? It have a different rule. Okay, we will speak about group 1, 2, and 13, 14 until 18. Again, group 1 have 1 electron. Group 2, 2 electrons. What about group 13? Group 13 have 3 electrons. So group 13 have 3. Group 13 have 3. Group 14 have 4 valence electron. Group 15 have 5 valence electron. Again, what is a valence electron? When we make a distribution or a Bohr model for the atom, the last energy level have only, as example, 5 electrons. Group 16 have 6. Group 17 have 7. Group 18 have 8. 8 electrons, and it is the maximum number of electrons at the valence electron. So, Mr. Valence electron group 18, which have 8 electrons, can they make any chemical bonding, chemical reaction? No. Group 18, we call it noble gas. Why we call it noble gas? Because they are stable. They don't make any reactions with any another atom. Why, guys? Because it have 8 electron at the valence, or it's have full set of electrons at the valence electron. All of them, yeah, mister? Yes, all of them. Let's speak about, as example, we will take مثلا carbon here have 6 electrons, so I will put C6. Let's make it. Okay, so C, that is a nucleus. The first level, it have 2 electrons. Okay, we have only we said have 4 now. Okay, second level, we have 4 electrons. 1, 2, 3, 4 as example. So it must be at group what, guys? Group 14, because have 4 electrons. Yes, it's group 14. Let's make it again. Okay, I will take another page. I will take as example مثلا element X. I don't know what's the element X, but I tell you the element X have 9 electrons. Can you tell me this element from which group? I will tell you that's very easy, mister. I will make distribution for the electrons. I will put X at the middle. Okay, the first level hold only 2 electrons, 1, 2, so I still have 7, right? Second level, it will hold 7 electrons, 1, 2, 3, 4, 5, 6, and 7 valence electron. So this element at group 17, let's check it. Yes, group 17 we have fluorine, which have only 9 what, guys? 9 electrons, so it is Fe, fluorine. So if I give you any element, okay, with a group of electrons, you can know, sorry, any element with the electrons number, atomic number, okay, you can know the family or group of for this element easily, very easily. Okay guys, let's go back to our lesson. Oh, and don't forget that the noble gas have, all of the noble gas have 8, okay, at the valence electron, except what? Except helium, because helium have only 2 electrons, so it is have full set of the first level energy, full set of the first level energy, so it's stable. It doesn't need to make any any chemical reactions. Okay, that's right. Okay, and element in each row, okay, we call them a period. Each horizontal row of element on the periodic table is called a period. The physical and the chemical properties of element change in periodic table, predictable ways from one end of the period to other. So the properties of the elements at the same period, they are different, okay, but at the same family they are the same properties, the same one, guys, the same. From this one, it is very easy, but it's very important, very important. You must know more about this part, and you must know, I must study this questions. It's very important, these questions. Okay, I can give you a lot of questions at this part. Okay, I can ask from you to tell me what is a valence electron. Maybe if I bring for you مثلا as example, let's take an example, helium, He2, and I ask you what is a valence electron at this element. You must make what, guys? Make a poor model. So you will put He at the middle, first level 2, and they have only 2, so the valence electron is what, guys? Is 2. Other question, lithium 3, okay, Li, first level 2 electrons, second level 1 electron, so we have 3 electrons now. So lithium at group 1. What's the family of the lithium? Family 1. Okay guys, it's very easy, I hope you understand it. I will give you another one, the last one. Okay, carbon is 6. Let's take another one, not carbon, N, sodium, nitrogen, N7. So N, the first level, it will have 2 electrons. Second level, guys, it will have we take 2 from 7, so we have 5. 1, 2, 3, 4, 5. So this element, nitrogen, we will found it at group 15, group or family 15. But how many valence electrons have? It have 5 valence electrons. Okay guys, it's very important, it's very easy. If you have any question, you can ask me about it. Thank you for listening, and goodbye. See you again, inshallah.